that might be a little bit better. Okay, so let's open up our lesson for today. So I'm going to share my screen. I just had someone exit. Oh no. Anyways, we will figure that out in a minute. I don't know if I am connected or not. Let's see. I understand, Nassim, that it is very laggy. We're just going to try our best for today. I'm going to record it, and if you need to go back and if you miss anything, I will have had recorded it. So we're going to try our best for today. I know that it's a little bit tricky, but I guess that's just the life we're living today. So we're just trying our best, okay? So for today, what we're doing is we are looking at our learning targets for today. So our learning targets for today, we have 2 of them, okay? Our learning targets are that I can, oh, no, I don't want to do that. I can explain what we mean by the solution to a system of linear equations. So you're going to be able to tell me what does it mean for something to be a solution. We talked a lot about this in that unit that we did, that little pre-unit that we did in between 1 and 2. So this is something that you guys should actually be able to answer right now. What does it mean for something to be a solution to systems of linear equations? And then also I can explain how the solution is represented graphically. So today is a nice sort of review day of what we did last unit. We're talking about systems. We're talking about what does it mean to be a solution of a system, and what does a solution look like graphically on a graph? What does a solution look like? So let's take a look at slide number 3. So slide number 3, we're talking about Diego. We have our buddy Diego, and Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound, and walnuts, you good, Adam? I don't know what that means. Raisins cost $4 a pound and walnuts cost $8 a pound. Diego spent a total of $15 on both ingredients. Decide if each pair of values can be a combination of raisins and walnuts. A combination of raisins and walnuts that Diego bought. So they cost $4 a pound, $8 a pound, and he spent a total of $15. You have to go through the 4 pairs on slide 3 and 4. You're going to take 2 minutes right now to go through slide 3 and slide 4 and decide if the 4 combinations with the cost per pound would be able to be spent, would you be able to spend $15. In these boxes right here, I need work. So you're going to go through all 4 of these right now. You're taking 2 minutes in deciding yes or no, they are a combination that would work and or add up to $15. Let me know if you have questions in the chat. You can start to put your answers in the chat as well. Nice job, Peyton. I love the explanation why. Nice job, Max. Perfect. Nice job, Peyton. Nice job, Gabe. Okay, I'm going to give you guys another minute. I'm just going to give you another 1 minute. And I want to see some answers in the chat. What are we thinking? Nice job, Connor. Nice job. We're taking another 1 for ourselves. Very good. Okay, so let's take a look at slide number 3, the first one here. So it says 4 pounds of raisins and 2 pounds of walnuts. So that would look like 4 times the 4 pounds plus 8 times the 2 pounds that we bought. So if we do that math, that's going to be 16 plus 16. And that is way too large. That is way larger than $15. That is $32, and that is not equal to the 15 that it should be equal to. So this guy here would be a no-go, guys. Very good. Nice job. Let's take a look at the second one here. The second one, let's see what people were thinking. Max said no. Peyton said no. Kyle said no. Let's take a look at this guy here. So this one would look like 4 times, ooh, let me try clicking in here. Oh my goodness, Miss Jermaine. Just give it a second, guys. Just give me 1 moment. Let's, awesome. So this second one here, we're going to say this guy is also a no-go because 1 times 4 is 4, plus 1.5 times 8 gets us a number that's way larger when we add them together than 16. So that is not going to work for this one here. Now let's take a look at number 4, slide number 4 here. We have this guy here where we're looking at 2.5 pounds of raisins and 0.75 pounds of walnuts. When we plug that in and we multiply 4 times 2.5, we're going to get $9 for the pounds of raisins, and then 0.75 times the 8 pounds for the, or $8 per pound for the walnuts is going to get me $6. 9 plus 6 is equal to $15. So this guy would be a yes. Awesome job on that one, guys. I saw a lot of friends tell me yes for that one. Nice job, Connor, Peyton, Kyle. Nice job. Very good. Now, when we look at this last one here, we have 2 sort of pieces to this one. So we would do 4 times 3.5. And I can't type on my slides right now. I don't know why, you guys, but we're trying our best. So I know why actually we can't, but that's okay. So 4 times 3.5 is going to get me $14. Okay, and then plus the 1 pound of walnuts is going to be $8. 14 plus 8 is going to get me $22, which is above that 15. Very good. So that one is not a solution. Very good. Nice job, Gabe. Wonderful, wonderful. So now, here we go. Let's take a look at slide number 5. Okay, slide number 5 is asking us now to write an equation to represent these constraints, right? So let X represent the pounds of raisins and Y represent the pounds of walnuts. So I need you to take 1 minute right now to write an equation for this scenario. Okay, so you're going to take 1 minute right now, and once you get it written down, I want you to write it in the chat so that we can take a look at it as a whole class. Okay, so take 1:15 right now to write out this equation here. Nice job, Kyle. Very good. Nice job, Kyle. Abby, nice job. Peyton looks good. Is this working? I don't know. I don't understand what is wrong with my internet right now. So I don't think I'm attached to the internet right now. Oh, I am. Good. Okay. So let's take a look. Sorry, guys. I'm so sorry about my internet issues this morning. It is okay. So our equation, everybody is doing very well with this. I'm so proud of you guys. So the equation that would be represented by this scenario. Very good job, Kyle. Okay, so we're going to say that it's going to be 4 times our x, which we said was our pounds of raisins. And we're multiplying the number of pounds of raisins that we buy times 4 because it costs $4 per pound. So we're going to say 4x plus $8 times the pounds of walnuts we buy. So it's going to be 4x plus 8y. It has to be equal to that $15 that we are going to spend as a group at the store, right? And Gabe actually threw some other pieces in here as well. He said that the x is cannot be greater than. Let me find the greater than symbol. Cannot be greater than 4, and y cannot be greater than 2. Nice job there, Gabe. That was really specific, sort of also constraints that we can represent using this greater than or equal to symbol. So very nice catch on there, Gabe. I wasn't thinking anybody was going to catch that, but nice job. So we can write this equation here, 4x plus 8y is equal to 15. And then from there, we're going to be able to say to ourselves, x is never going to be greater logically in this scenario cannot be greater than 4 pounds, and y cannot be greater than 2 pounds. Nice job there, guys. Awesome, awesome, awesome. Let's take a look at this next piece here. So now what we're going to be doing is we are going to be graphing this scenario. So we're going to use this graphing tool here to graph this equation. And then we're going to create this, we're going to fill in some of these data points here. So actually, I think I'm gonna have us, before we do the graphing piece, guys, I want you to take 1.5 minutes right now to fill in these data points right here. When you buy 0 pounds of raisins, how many pounds of walnuts can you buy? When you buy 0.25 pounds of raisins, how many walnuts can you buy? I want you to take 1.5 minutes right now to fill in these pieces of information first. Okay, so you're taking 1.5 minutes to fill in this table first, and you can get started. Okay, so once you start getting some answers for this right here, we're taking 10 more seconds. When we have 0 pounds of raisins, let me know in the chat, how many pounds of walnuts can we buy? What are we thinking, guys? Very good, nice job. I want to get a few more people in the chat. How many pounds of walnuts can we buy? Very good. Nice job, Gwen. Nice job, Max. Nice job, Gabe. Nice job throwing that label on there, Gabe. Very good. 1.875. I would write it with the 3 decimals here because it terminates at the 3 decimals. So I would write all 3 so that it's the most precise that it can be. Very good. Then when we had 0.25 or 1/4 of a pound of raisins, how many pounds of walnuts could we buy? 1.75 pounds. Very good. Nice job. When we had 1 in 375 thousandths pounds of walnuts, we could buy half a pound of raisins. Very good, nice job. And then when we have 1.25 pounds of walnuts, we can buy 1.25 pounds of raisins. Very good, nice job. And when we have 1.75 pounds of when we have 1 in 75 hundredths pounds of raisins, we can buy 75 hundredths pounds of, or 3/4 of a pound of walnuts. And then when we have 3 pounds of raisins, so 3 times 4 would get me 12. We would be left with 3. So 3 divided by 8 would get me 0.375 pounds of walnuts. Okay, so that was what we had to do for this piece here, was we had to plug in the piece of information that we knew into the equation and then solve to isolate that other variable. So for example, you would be solving and isolating for this one here. We solved and isolated for this y here. And then for when this one was blank, we were solving or isolating for that x. Okay. Very good job. Nice job. So what we're going to do now is we're going to use this graphing tool here. So if you click on this Desmos link here, guys, it's going to take a minute to load. I understand that. And we are going to graph this equation here. Okay, and the way that we graph things in Desmos, let's take a look, make sure we're paying really close attention, is over here on the left-hand side, you're going to click in this little line that says the number 1. You're going to click in there, and you're going to simply type in that equation. So it would be 4x plus 8y is equal to, how much did we say that it was equal to? Let me know in the chat. How much did we say it was equal to? Nice job, Kyle. Nice job, Peyton. Nice job, Gabe. Is equal to 15. So when we type that in, let me just pull it over so we can see it a little bit better. When you type your equation in there, this is what's going to pop up. And what we need to do now is we need to save this picture here. So we need to take a picture of that. And that on your keyboards, remember, you hit Control, Shift, and then the button that looks like this on your keyboard. I don't know, can you guys see that? The button above your 6, okay? And it will take a picture of this screen right here, and you're going to put a box around it and have that be your picture. So let me see if I can do that on mine. I think I just did it. Let's see what happens. You're going to come back to here, and you're going to paste it in for yourself. So you're going to go Insert, Image from Drive, and you're going to insert it in there. If you're having trouble with that, let me know in the chat. Okay, so once yours is going to look way better than mine. I had to do a little bit of cropping with it, but this should be what your equation looks like. So we will be graphing things a little bit more this unit using Desmos. So you want to be able to click on that link and just type it right in this first bar right here and take a picture and insert your snapshot. Let me know in the chat if you are not able to get a picture of your snapshot on your slideshow. Okay. So we're going to be closing off. Let me see how much time we have. Mr. Main is very much like thrown off today for some reason. That is now full screen. Let's take a look. Okay. It's not letting me. Okay. Not letting you do what, Ava? Insert it or take the picture? Oh, you don't have a school Chromebook, do you, Ava? So what the button that you need to press on your keyboard, and it's in a bunch of different spots depending on what type of keyboard you have, is a print screen. So it says PRTSC, or it might actually say like print screen if your computer is big enough. Does that make sense, Ava? Perfect. So you print screen it just like I did, and then you're going to have to like crop it down. But if you have trouble cropping it, you can just insert the picture. Ava, it's not a big deal. Okay. Awesome. Thank you, Ava, for that. Let's take a look at slide number 7. Okay, so now, okay, Diego spent $15 and bought exactly 2 pounds of raisins. And let me see if I'm missing a number. So he bought 2 pounds of raisins and 2 pounds of walnuts. Oh, no. Oh, he bought exactly 2 pounds of raisins. I'm sorry. And walnuts. How many pounds of each did he buy? Explain how you know. So basically, this is worded a little bit weirdly. So he spent a total of $15. He bought 2 pounds of raisins and he bought some walnuts. We don't know how many walnuts he bought. Your job right now is to decide and to calculate how many pounds of walnuts he can buy if he buys exactly 2 pounds of raisins. Okay, so I want you to work it out in this box right here. I want you to figure out how many pounds of walnuts he can buy if he buys 2 pounds of raisins. Okay, so I want you to take 1:30 right now to figure out how many pounds of walnuts he can buy if he buys 2 pounds of raisins. Okay, sorry about the wording on that, guys. Nice job, guys. We have another 58 for ourselves, another 58 seconds. Oh no, Mr. Main. Read the question wrong. It's okay. Okay, wonderful, wonderful. I'm going to stop you guys there. Okay, so let's think about if he bought 2 pounds of raisins. I would plug 2 in for which variable, X or Y? Very good. Nice job, Abby. Very good. Nice job, Connor. Nice job, Gwen. Awesome job, Gabe. Very good. If we would plug the 2 in for the X. So we would say 4 times 2 plus 8 times Y, or 8Y. Okay, and then when we do that, we get 15 is equal to 4 times 2 is 8 plus 8 times Y. We would subtract our 8 from each side. We would be left with 7. 7 is equal to 8y. Divide by 8. Divide by 8. We would get y is equal to 0.8. 0.875. Okay, so now I want to think about it in terms of we're going to the store and we're buying exactly 2 pounds of stuff, right? So I'm buying exactly 2 pounds of raisins and walnuts whenever we add them together. So we're not buying 2 pounds of each this time. We're looking at it as we're buying 2 pounds of everything. Right? So in total, I'm walking out of the store with 2 pounds of product. So that means I need to create a new equation to figure out how many pounds of walnuts plus how many pounds of raisins is going to get me that total of 2. So if we're looking at the scenario now of we're throwing in a constraint of we can only buy exactly 2 pounds of seeds, really, because it's like raisins and walnuts. Well, raisins aren't really seeds, but Snick Snacks, we're buying exactly 2 pounds of Snick Snacks. We can write a second equation of x plus y is equal to the 2 pounds. Does everyone see how we sort of created a new equation from this with this new sort of constraint here? So we have a new constraint that we have, and he's spending the $15 and he's buying exactly 2 pounds of raisins. So we're going to still use this original equation to figure out control copy. We're going to use this equation right here to figure out how much he's going to spend, or how many, or when we're talking about the total amount of money that he spent. And then if we want to constrain him to buying exactly 2 pounds of Snick Snacks, we would write the second equation of x plus y is equal to 2. So now we're going to be dealing with two sort of equations here, which we call a what? When we have two equations that we're using for a story, we call that a what of equations. What do you think? When we're dealing with two equations now, we call that a systems, or not a sequence, a systems of equations, right? So when we have two sort of guys here, like we did, like we dealt with in our last unit, when we have two equations that we have that pertain to the same story, we're going to call it a system of equations. Okay, and now let's take a look at these last few questions before we head out for today. It says, can you find other combinations of raisins and walnuts besides 0.25 and 1.75 pounds that meet both cost and weight constraints? Nice job, Nassim. Very good. So is there another combination that satisfies both sort of scenarios here, that it has to add up to a price of $15 and you can only buy exactly 2 pounds of stuff? So is there another, if we're given this scenario, I mean the point of 0.25 and of walnuts and 1.7 pounds of raisins, is there another combination that we would be able to match that would, when you think about it, sorry, Mr. May, when we think about a systems of equations, how many solutions do most systems of equations have? One, infinitely many, or no solutions? Nice job, Gabe. Most systems of equations have one solution. It's very, I mean, I know that I give you, when we go through and we're going through and we're doing these in class, I give you an equal amount of each, but when we're in sort of regular math, or when you're out in the regular world, most systems of equations only have one solution. So this guy right here, this systems of equations right here is only going to have one possible combinations that would fit both of the constraints, because we're dealing with such a small pool of data, and we can't have negative numbers. If we were dealing with negative numbers, or really negative numbers, then we would have multiple solutions to that system. But because we have such a narrow constraint here of they have to be both positive between 2 and 4, we're only going to have one solution for this guy. So this guy is only going to have one solution to this systems of equations, okay? So when you have a systems of equations, it's very rare, and if we look at this also, it's not going to have infinitely many, because if we multiply by 4, then we would get the 4x, but we would get the 4y. And when we have infinitely many solutions, the x and the y value need to be the same, right? And they need to be equal to the same number. And so there's no way that we can sort of manipulate the second equation down here to get it so that it looks exactly like this first equation. So this is only going to have one solution to it. Okay, so how many different possible combinations are there? There's only going to be one possible set of combinations. Okay, and how do we write a systems of equations? What is the solution to the system below? So we have our systems of equations written here for us. What did we say the solution was to our systems of equations? Let me know in the chat. What did we say the solution was? Writing it as an ordered pair of x, comma, y. What is the solution to the systems of equations? What is that point where they hit and where they crisscross? Let me know in the chat. What is that coordinate pair, that x comma y, that is the solution to the systems of equations? I'm going to give some wait time because I want to see what people are thinking. What is the coordinate pair that is the solution to these two systems of equations here? Put it in the chat for me, guys. I know the internet is a little bit wonky today, so I'm going to give another couple seconds for you guys to think. How do you write an ordered pair? Very good job, Ian. Very good job, Gabe. Very good. Nice job, Connor. What are the, what are you missing though? There's something that you're missing. Nice job, Gabe. Ian, why don't you fix that ordered pair? How do you write an ordered pair, my friend? Nice job, Gwen. We're just going to flippy floppy that the order there, because we're saying, so it's given to us in raisins and walnuts, and so we're going to read that as the first number is raisins because raisins came first, and walnuts is the second number because walnuts in the sequence of the two words came second. So we would write it as x comma y, and we said that our x was our raisins, so it would be 0.25 comma my second number, which is our y or our walnuts, 1.75, and then close the parentheses. Okay, so we're talking about, the only thing it doesn't say in here would be respectively, and that word respectively means that when we have a list of two things and then we list off two other like corresponding numbers and we say respectively, so we say we're talking about combinations of raisins and walnuts besides 1.25 and 1.75 respectively. So that means the first number corresponds with that first word. The second number corresponds with the second word, okay? So we would write it as 0.25 comma 1.75, okay? Awesome job. So ladies and gentlemen, let me tell you what you are doing for this afternoon. Okay, so if you look on the slideshow for today, the afternoon work is the afternoon work assignment for today. It's posted in the classroom section, and it is a Google Forms that you need to go through and complete. Okay, so it's not going to take you 30 minutes. It pertains to what we did in class today. It is posted already. So if you come into, let's see if this works. Just give me like 20 more seconds of your time. I want to make sure that this is going to work. If you go into the classroom, it may take a little bit of time to load. Just give me 1 second, guys. And you come into the classroom. It says 1/04 afternoon work. You click on it, and all it is a link to there's no work here because it is a Google form. Okay, and make sure that once you complete it, you hit the turn in button on it. It is just a Google form that you're going to go through and work on, and you're going to answer some questions about some systems of equations on graphs. Okay, talking about solutions. What do solutions mean? What do all of these different things mean on when we're talking about systems of equations? So that is your afternoon work for today. It's not going to take you 30 minutes, but it probably will take you maybe 15. So I want you trying your best and hitting submit when you finish it. You can submit the slideshow for today. We will be working on something. We're going to be expanding on this tomorrow. Today was a nice little review day, not too big, not too much new information. And yeah, does anybody have any questions for me before you leave? No? Okay, so if you're working this afternoon, you're on the Google form and you have questions, please shoot me emails. I will be available today. The only time I'm not available is from 1 to 1:30, okay? So if you guys are all set, I will see you all tomorrow. Awesome job today. If you have any questions, please let me know. I will see you all tomorrow. Please make sure that you guys get here on time. Bye, guys. Elliot, make sure you check your email today because I'm going to be reaching out to you about your moves moving forward, okay? Because I'm going to talk to Miss Karen today. Bye.
I won't be able to come to class tomorrow. I have to go to a funeral.
Okay, that's no problem. I'll record it and maybe just try to watch it before class on Wednesday.
Okay.
So I'll have you for tomorrow just because if you're not going to be in school tomorrow, just stick with like what we're doing here and then I'll talk to Miss Karen today, okay?
Yeah, because I got an email from Miss Quinto.
Yep, Miss Quinto. She's the ELA teacher.
About my schedule for Green Hills.
Okay. So when did she say anything about when you were going to start?
She said I was supposed to start on the 19th, but
On the 19th?
Yeah, but I might start this week.
Okay, that might be a good idea. I will shoot Miss Karen an email. So I will let you know either today or tomorrow who you should be following. I would suggest though, at least for algebra, you watch tomorrow's lesson because I don't think Miss Karen records her lessons and posts them. So it'll be a good idea just to at least watch mine. And then if she has you complete something, you can complete it through hers.
Okay.
Okay.
Bye.
I'll reach out, okay?
Okay. Thank you.
Bye, Elliot.
Bye.
Hey, Cam, how you doing, buddy?